Do you want to extract information from semi-structured text and look for a solution with as little programming as possible? No if-then conditions, without program code. You think that's not possible at all. Here I show my preferred method using Apache Spark as an example. But you can apply the idea of decomposing text to many other tools and programming languages too. Analyze structured text data with Apache Spark. This video shows you how to decompose almost arbitrarily complex strings and convert them into a data frame with just one command. The workflow is so intuitive and straightforward that you will be amazed. That's a promise. The first step is to understand the text data. We look at the source data with a human eye and search for patterns. Now we develop a regular expression to decompose the text. With the right tool, this can be done intuitively and interactively. In the following, we load the data into Apache Spark. This is done line by line. The actual exciting part, the connection of Apache Spark, a user-defined function, and the regular expression takes place in the next step. The source text is now broken down into defined parts. Finally, the data frame is optimized by setting additional data types. Access log analysis. We use a log file from a web server for demonstration. The structure is line-oriented. In example, each line contains exactly one record. This is the case with almost every application log. With the naked eye, we can see structures and patterns in the data. For the expert, such a file reads like a book. A computer has a little more difficulty with this format. If you look closely, you can see tabular structure. Each line follows the same pattern, only the data is different. The line starts with an IP address, followed by a timestamp, a request string, the HTTP status, the content length, and the user agent. Regular expressions. We now develop a regular expression that we apply to each line. Capturing groups are used in the expression. These capturing groups allow us to conveniently decompose the line into many sub-expressions. The special clue is the naming of the groups. Each sub-expression can be referenced by its name. And last but not least, we try to keep the expression simple. It is not about performing complex validation of data. Rather, the regular expression should help us to process all rows. In the end, each row is decomposed into key-value pairs where each key may occur exactly once. Grokking regular expressions. We can call the GROK debugger from the browser. It can handle the naming capturing groups and helps us to develop the regular expression interactively. In the upper field, there's a line from the access log file. The regular expression is stored in the field below. To understand how it works, let's start by creating the expression. The IP address forms the beginning of the line and is ended with a white space. In the first capture group, we now have to group all non-blank characters together and concatenate them with the IP key. I'm not interested in the following two fields, but I have to include them in the expression. I name them F1 and F2, and again use space as a terminator. If we have done everything right up to here, the search result is now displayed below. There are now 3 key-value pairs to be seen. With the date, it becomes now somewhat more complex. I'm not interested in the square brackets. In the regular expression, I place them outside the capture group. The separator for the next field is a closing square bracket. So all characters up to the occurrence of the bracket are included in the group. For the request string, we proceed analogously. But here, the field delimiters are quotes. The HTTP status again uses the space character as a separator. And the content length follows the same pattern. As the expression grows, the extracted data appears at the bottom. When the regular expression is complete, it is validated against other selected lines. In the end, it must work with every line. Loading data into Apache Spark. The access log contents must be made available to Apache Spark for further processing. To do this, I first open the interactive Spark shell. And next, I load and review the data here. Loading text content is quite simple in Apache Spark. I use Spark from a Docker image. The image is loaded and then started. After a short wait, the Spark shell prompt appears. When the shell starts, it loads an extension. This extension contains a user-defined function. Note that this function is not part of the default Apache Spark distribution. It's a function that I created myself. It accepts a regular expression with named capture groups. In that way, the function acts like the GROK debugger. As a result, text fields are split into sub-expressions and assigned keys. The named groups are finally found in the data frame. And if the expression does not apply, the target field is pre-allocated with a 0 value. But one step at a time. First, I load the file contents of the access log into the data frame. Each line of the file is now an entry in the data frame. The output in the console is right-aligned, but the individual lines are easy to recognize. The schema also consists of a field of type string. The inspiring thing happens in the next step. Here, we apply the user-defined function to each row and use the regular expression as a parameter. As a result, a second column called details becomes visible in the data frame. A look at the schema reveals many more columns, and the names of the capturing groups correspond to the field names. The table now consists of several columns. Up to here, all columns are of type string. Fortunately, type conversion Apache Spark is very simple. I convert the date and some numbers to other types using data frame operations. You can see how easy it is to adapt the data frame. Did you like this example? Do you have any questions or suggestions? Let me know and write in the comments. I look forward to your feedback. Thanks for watching.